In the last video, we examined Gopnik's argument that folk psychology is learned in essentially the same way as scientific theories are learned. Interesting idea, but it faces a host of objections. These problems with Gopnik's theory push us to the view that folk psychology is largely innate. Obviously any innate trait requires the right environment. So to say that folk psychology is in some sense innate is not to say that the environment has no influence. Instead, the thought is that folk psychology is a psychological adaptation. We might compare it to physiological reflexes. So if you perceive an object moving towards you at high speed, you'll immediately duck out of the way. That's an immediate reflex that has been ingrained in us by evolution. But obviously there are circumstances that can erode reflexes. If an organism is simply starving because it just hasn't had enough food, or if it's delirious due to illness, its reflexes may no longer be triggered. Now obviously folk psychology is far more sophisticated than a simple reflex, but the thought is that it similarly might have a kind of evolutionary background. This view of folk psychology is closely linked to evolutionary psychology. I have a video on evolutionary psychology that would probably be worth checking out, but for our purposes here, there are two ideas of evolutionary psychology that are important. First of all, the basic claim is that certain psychological traits evolved to solve problems that faced our ancestors. It's easy enough to see how folk psychology fits into this. The evolutionary problem is comprehending the behaviour of other people, especially as social relations became more complex. In the primates in particular, social relations have become increasingly sophisticated, and so there's a kind of evolutionary pressure to solve various problems that arise as a result of that. I mean, just look at the way that cows and sheep, or even dogs or cats interact. Obviously, they do have social relations, but generally speaking, it's really quite simple. It's striking how little sort of social interaction actually goes on. But in the primates, it became increasingly complex, and so there was pressure to solve this problem of social coordination. And the solution is folk psychology, which is a theory about why people behave the way they do. We have evolved an innate tendency to develop certain theories of other people. Second, traditionally we tend to view the mind as being composed of a few general purpose capacities. The mind is a sort of general purpose system. It has these general purpose capacities that can be applied in many different circumstances. Consider rationality or reasoning. We traditionally think that we have a capacity for reasoning, and we can apply this reasoning capacity to many different tasks. So tracking a deer, or doing high-level mathematics, or preparing a meal, or engaging in political debates, or identifying why your car won't start. Underlying all of these tasks is a general mechanism for making inferences and for forming beliefs. This is a kind of view that Gopnik holds. For Gopnik, what evolution has endowed us with is a general purpose reasoning and learning mechanism, and the child scientist applies this general purpose mechanism to develop the theory of folk psychology and many other theories. And of course, as the child gets older and as it becomes an adult, it continues to apply this general purpose mechanism to many other things. In contrast, evolutionary psychologists hold that the mind has few, if any, general purpose capacities. Instead, the mind is composed of a variety of highly specialised modules that perform specific functions. This is known as the massive modularity hypothesis. So what exactly is a module? Well, as evolutionary psychologists understand them, modules have two important properties. First, they're domain specific, which means they are specialised to solve a particular class of problems. We might have a module for basic physics, So that's a module that provides us with a basic understanding of how objects move and interact. We might have a module for mate selection, which tells us what to look for in sexual partners. Perhaps there's a module for avoiding contamination and disease. Modules devote themselves to specific tasks. Second, modules are informationally encapsulated, which means they tend to be unaffected by other processes going on in the mind. They all work independently. So the claim that the mind is massively modular means that the mind is nothing but modules, these sort of domain-specific and independent mechanisms. And it follows that we develop folk psychology thanks to an innate module or modules devoted specifically to folk psychology. We don't work out folk psychology by applying a general capacity for reasoning, because there is no such capacity. Why should we think that the mind is massively modular? Well, the basic thought is that natural selection produces structures that perform specific functions. Eyes are for seeing, teeth are for grinding down food. Eyes can't do what teeth do, and teeth can't do what eyes do. Indeed, these traits are both even more specialised. Human teeth are specialised into canines, molars, incisors, and these perform different functions. The human retina is split into cones, which are involved in colour perception and daylight perception, and rods, which are adapted for seeing in the dark. And cones and rods work largely independently, to the degree that many vision scientists prefer to see the human eye as actually built from sort of two overlapping retinas, one made of rods and one made of cones. There are several reasons for specialisation in evolution. The main point is simply that general purpose mechanisms are far less efficient. Taking the human retina, for example, it clearly makes sense to have a separate system dedicated specifically to low light conditions. Rods have to trade the high sensitivity to light for a low acuity of vision, and there's no ability to discriminate colours. If we tried to do all things with one type of photoreceptor, it would have to make all sorts of compromises. Similarly, just consider a mechanism that, say a mechanism that can both crush and stab. Well, a mechanism that specialises in crushing, and a mechanism that specialises in stabbing, will probably be better than a mechanism that does both. In order for a mechanism to do a variety of tasks, it has to make a bunch of compromises. A jack of all trades is a master of none. So that's why we get specialisation. For psychology in particular, there are more specific points. First of all, if you want to find your way around the world efficiently, you need to avoid errors. And in order to avoid errors, you need to know what counts as an error. Now, the problem is that what counts as an error differs from domain to domain. There is no domain-independent standard of error. Leda Cosmides and John Tooby give the following example. They say, in the sexual domain, error equals sex with kin. In the helping domain, error equals not helping given the appropriate circumstances. In cooperative circumstances, error equals being cheated, which is paying a cost without receiving the benefit to which this entitles you. So imagine that a domain general learning mechanism figures out that the individual shouldn't have sex with close relatives. It's not actually clear that a domain general learning mechanism could do this, because it takes quite a lot of time for the drawbacks of incest to become obvious. But let's say it figures out not to have sex with its kin. Now, how do we prevent over-specialisation? How do we make sure that the rule that the organism adopts is specific to its appropriate domain? How do we prevent rules like avoid any interaction with kin or avoid touching kin? Those rules would obviously be maladaptive. Domain general mechanisms are liable to make faulty generalizations. Second, the problem of combinatorial explosion. Take any problem related to survival and reproduction. Suppose you've moved into a new environment and you need to find food. The question is, what should you do? Well, if you consider all of the options available to you, there's a practical infinity of actions you might take. Most of them are very silly. Twirl around in a circle for 5 minutes and then go to sleep. Or try to jump to the moon. That's not going to help you find food, obviously. Now, of course, when we're faced with a problem, we don't actually evaluate all of the alternatives. If we're looking for food, we don't have to think through all of the possible actions. If we did, we'd never be able to do anything. There'd be too many to consider. Now, the point is that a domain general system lacks specific knowledge. It lacks specific rules of relevance and specific procedures. In which case, how can it zero in on the relevant alternatives and ignore the silly ones? This problem is solved if we suppose, as evolutionary psychologists do, that when we're faced with a problem, a domain-specific module is activated, and that brings with it specific knowledge and specific procedures. Again, I recommend checking out my video on evolutionary psychology if you want more detail, but the conclusion that evolutionary psychologists draw is that we have various independent psychological modules specialised to solve the different problems that our ancestors faced. These modules are innate, they are part of our biology. Provided a child is given the basics it needs to survive and thrive, it will develop these psychological modules. So we are born with a great deal of knowledge and rules and abilities already written into our minds. As we noted, one of the most significant problems for our ancestors was social coordination. The theory of folk psychology is an adaptation to solve the social coordination problem. It arises from the action of innate modules that deal with social interaction. This is at least a plausible hypothesis. It probably seemed rather curious, actually, if there were no innate mechanisms of social cognition. Now, there are various lines of empirical evidence for cognitive modules. Again, I discussed some of these in the evolutionary psychology video. But for the idea that folk psychology itself might be modular, support for this suggestion comes from the persistence of folk psychological judgments. Consider visual illusions. Here's a famous illusion known as the Muller-Lyer illusion. The top line looks shorter than the bottom line, but if you measure them, you'll find that they are exactly the same length. Now, notice that your judgment that they are the same length makes no difference to your perception. Even after you know that they're the same length, they still perceptually seem to be different lengths. And this suggests that at least part of the visual processing system is modular. The visual system is unaffected by higher level judgments. It's not susceptible to kind of influence from any kind of any part of our reasoning capacities or anything like that. At least part of the visual system is, to put it in technical terms, informationally encapsulated. Now, we find exactly the same kind of thing with folk psychology. Just go and watch a cartoon, for instance. You know that Homer Simpson doesn't actually have a mind. Indeed, Homer Simpson doesn't even really exist. But you can't help but interpret Homer Simpson as minded. We can't help but talk about his beliefs, his desires, his personality. Even though we know he doesn't actually have a mind, that we just can't help but see him as being minded. Particularly striking evidence of this is provided by a famous study in 1944 by Heider and Simmel, which they gave in the paper An Experimental Study of Apparent Behaviour. Heider and Simmel asked subjects to watch a film showing a few abstract shapes moving around. Here's a frame from the film. You can look it up on YouTube if you're interested. The whole film is on there. Just type in Heider and Simmel animation or something like that. Anyway, they then asked subjects to describe what happened in the film. Now, interestingly, almost everybody spontaneously described the shapes as having desires, goals, beliefs, personalities. Almost everybody attributed minds to the shapes, even though it's obvious that the shapes don't have minds. Here's part of one subject's description. He says, "A man has planned to meet a girl and the girl comes along with another man. The first man tells the second to go, the second tells the first and he shakes his head. Then the two men have a fight and the girl goes into the room to get out of the way and hesitates and finally goes in." And this subject continues in much the same way. He even attributes genders to the shapes. So the shapes are attributed with a whole battery of folk psychological concepts. I recommend checking out Heider and Simmel's film. It's striking how powerful the temptation to ascribe minds to the shapes is. Just try to describe what happens in the film without using any folk psychological terminology. There's a good chance that you'll end up using a term that implies mindedness, even if you try not to. So it looks like folk psychology is also informationally encapsulated. We make folk psychological judgments automatically, even when we know that it's not applicable. And this supports the modularity hypothesis. Another line of evidence for modularity comes from autistic children. Consider the false photograph test. In this test, children are shown first how a Polaroid camera works. We don't really use Polaroid cameras anymore, but these cameras immediately print a picture. You take the photo and the camera immediately prints the picture. The picture is initially blank and it gradually develops. So in this experiment, the child observes a scene in which a toy cat is sitting on a chair. A Polaroid is taken of the scene. The Polaroid, the photo that's produced is then placed face down on the table as it develops. The experimenter then changes the scene by moving the toy from the chair to the bed. And the child is asked, in the photo, where is the cat sitting? Younger children will assume that the photo shows the cat on the bed, where the cat has been moved to. Older children will recognise that the photo will still show the cat on the chair before it was moved. Now this relates in an interesting way to the false belief test that we saw in the previous video. Normal children will pass both the false photograph test and the false belief test by about 4 years of age. On the other hand, autistic children will pass the false photograph test at 4, as usual, but will be about 9 or 10 before they pass the false belief test. The failure to pass the false belief test, but not the false photograph test, suggests that there's some specialised module for dealing with beliefs. We don't apply a generalised reasoning mechanism in each case. In autistic children, the folk psychological modules are impaired, but other modules may function as normal. Even autistic children that have relatively high intelligence in other respects fail simple false belief tasks, but succeed at the false photograph tasks. It's also worth noting that children with Down syndrome pass false belief tasks at a normal age, despite impaired general intelligence. Children with ADHD are also able to pass at a normal age, despite attention problems. Again, this suggests that the capacity for folk psychology is modular. It's not a product of a general reasoning capacity. Children with Down syndrome and ADHD are impaired, have cognitive impairments in many respects. They may have sort of impaired general intelligence, but folk psychology, they appear to learn it as normal. So there seems to be a dissociation between folk psychology and other capacities, which would suggest that it is modular. This is especially this relation between the false photograph test and the false belief test is especially notable, given that both beliefs and photographs are representational. Beliefs and photographs represent things in the world. You would expect that if a child can understand that photographs can falsely represent, she should also be able to understand that people can have false beliefs. But as I said, autistic children understand that photographs falsely represent, but they don't get false beliefs until much later. So it looks like the mechanisms involved in understanding beliefs are dissociable from mechanisms involved in understanding representations in other contexts. So what exactly are the modules involved in folk psychology? Well, obviously there's a lot of debate about this. Simon Baron-Cohen, in his book Mind Blindness, suggests 4 components of the folk psychology system, and I think that these are good candidates for innate modules, although I should note that Baron-Cohen himself is a bit less committal about this. But anyway, Baron-Cohen suggests that we have an intentionality detector. This device immediately attributes volitions based on motion. It immediately attributes objects in the world with goals and desires based on how those objects move. Generally, anything that exhibits self-propelled motion will activate the intentionality detector. So we see a mouse moving towards the cheese, and we conclude it wants to get the cheese. We see a deer running from a tiger, we conclude it wants to get away from the tiger. Anything that could be an agent activates this detector. Recall the Heider and Simmel study. Remember, they're just talking about shapes. The point about these shapes is that they exhibit self-propelled motion, and they seem to interact in goal-directed ways. Imagine instead an animation showing two circles. The second circle is still. The first circle moves in a straight line and collides with the second. The first stops moving. The second starts moving in the same direction the first had been moving. In that case, there'd be no tendency to attribute mental states, because the circles exhibit only basic physical motion, like billiard balls. Most people won't attribute minds. Of course, you could attribute minds, but generally speaking, people will just describe that, as well. One object is sort of moving and hits another object, and the other object starts moving. They won't attribute minds. So it's self-propelled motion that tends to trigger the intentionality detector. Second, the eye direction detector. This detects the presence of eyes, and it determines in what direction the eyes are pointing, and it infers that if an organism's eyes are directed at something, then the organism sees that thing. Infants look at eyes significantly more than any other part of the face or body. 6-month-olds will look between twice to 3 times as long at eyes looking at them than at eyes looking away. Furthermore, when an infant sees a pair of eyes looking at it, this will trigger physiological arousal. This is the basis of the game of peekaboo, where an adult covers and then reveals her eyes to the infant. That is literally, when the infant sees the eyes, that literally triggers physiological arousal in the infant, sort of pleasurable feelings. Eye direction tells us a lot about a person's goals. Look at this image. We are immediately drawn to the judgment that this person wants the sweets on the bottom right, the polos. So are toddlers. If you ask 3-year-olds which one does Charlie want, they will immediately identify the ones on the bottom right. Now, the intentionality detector and probably the eye direction detector are quite primitive mechanisms. Possibly they emerged very far back in the past, and they're shared with many other animals. The most we get are judgments like, X wants cheese, or X sees me. A more sophisticated module is the shared attention mechanism. The shared attention mechanism builds triadic representations, it builds representations of a relation between 3 things: yourself, another agent, and an object, where the object might be another agent. So we get a judgment like, you and I see that we are looking at the same object. The shared attention mechanism considers another agent's perceptual state, and it relates it to one's own perceptual state. This begins to develop at about 14 months, when the child starts to exhibit gaze monitoring. So when the child sees somebody gazing, it looks in the direction that the person is gazing. It then looks back to the person, and then back to whatever they're looking at, and then back to the person, and so on. Basically, the child checks back and forth to make sure that it and the other person are both looking at the same thing. Around the same age, the child learns to point. It will, again, alternate its gaze. It will look at the object it's pointing at, and then it will look back to the other person to make sure the person is looking in the direction of the pointing. So, by this age, there seems to be an awareness that both yourself and another person inhabit a shared world. And obviously the shared attention mechanism builds on the eye direction detector. The primary means by which we establish shared attention is through eye direction. Arguably, most sophisticated animals have some sort of eye direction detector. Humans and perhaps a few other primates have another module which employs the eye direction detector to establish shared attention. It establishes knowledge of a shared world, a shared experience. Now, if folk psychology employs the eye direction detector and the shared attention mechanism, we should expect that folk psychology would be impaired in blind children. And that is what the evidence shows. Blind children tend to fail false belief tests even up to the age of 6 or 7. So it does seem that folk psychology is delayed in blind children, as we would expect on this view. Finally, the theory of mind mechanism. This is the most sophisticated module, and it's basically what gives us full-blown folk psychology. It builds on the other three modules, but it elaborates them by providing a battery of new concepts. First, this mechanism provides a way of representing epistemic mental states. So these are states like believing, imagining, pretending, thinking, deceiving, guessing, and so on. And second, this ties these epistemic mental states together with the earlier mechanisms. So the earlier mechanisms give us concepts of volitions, desires and goals. They give us concepts of perceptual states, and they allow us to understand that different people can experience the same objects or events as us. Now, once we add epistemic mental states, we begin to understand that other people can have false perspectives on the world. Other people can be mistaken about the world. This is what the false belief tasks measure. We can also relate epistemic mental states to the satisfaction or frustration of goals and desires. Frank wants chocolate cake and believes he will receive chocolate cake, which makes Frank happy. Maybe Frank is wrong and he won't receive chocolate cake, so it's a false belief. But because he believes that he will, that's enough to make him happy, given that he wants chocolate cake. So, this is one picture of the modules involved in folk psychology. One thing that may be worth noting at this point is that splitting folk psychology into modules perhaps allows us to broker a compromise between Gopnik and the evolutionary psychologists. Perhaps we could argue that the first three modules, the intentionality detector, I-direction detector, and shared attention mechanisms, perhaps they are all innate, while the fourth, which gives us full-blown folk psychology, is learned like a scientific theory is learned. I mean, it seems that there's really no doubt that the intentionality detector is innate. Any moderately sophisticated organism will need something like that to get by in the world. And it's pretty plausible that we also have an innate tendency to fix on eye direction and to establish shared attention. But now notice that if evolution has provided us with these three modules, it's not so difficult to see how we might be able to learn the theory of mind. Once the first three modules are in place, it's actually quite a small step to getting the epistemic mental states and to relating those to the judgments of the earlier three modules. So maybe some sort of compromise view could be developed here. Now, before we end, I'd like to note an interesting consequence of the theory. Theories are fallible. If folk psychology is a theory, then it seems that at least in principle it could be mistaken. We might be radically wrong about the nature of the mind. Just as we once believed that a substance called phlogiston was released during combustion, but that turned out not to exist, and just as we once believed that light consists of waves in a subtle fluid-like substance called the luminiferous ether, but we now know that the ether doesn't exist, well, perhaps we're also wrong that beliefs and desires are the causes of behaviour. Perhaps there just are no beliefs or desires or emotions or moods or anything like that. This is exactly what has been suggested by some philosophers, most notably Paul and Patricia Churchland. This is the view known as eliminative materialism. It's the idea that folk psychology is radically mistaken. It is just totally wrong, and it will be replaced by whatever theory is developed by advanced cognitive science. So you can check out I have a couple of videos on eliminative materialism if you're interested in that rather radical view. Now, questions like this won't really concern us for the remainder of this series. What we're interested in this series is the question of how do we actually, in fact, go about predicting and explaining the behaviour of other people. The question of whether our common sense theories are correct is a separate issue. So what we're interested in is, do we in fact use this folk psychology theory to explain and predict the behaviour of other people? Whether that theory is a correct theory is a different question, but a very interesting question. So again, you should have a look at those videos if you want. Right, that's all. Thanks for watching, and next time we will examine the simulation theory of folk psychology. Goodbye.